Good morning, students. Today I am going to discuss about previous exam questions and answers of MFCS paper. So the question is, solve the recurrence relation an minus 5an minus 1 plus 25an minus 2 minus 24an minus 3 equal to 6 for n greater than or equal to 3. To solve this question, first, find the order of the recurrence relation. This is third order recurrence relation. So we have a cubic equation. Now write down 1r cube minus 5r square plus 25r minus 24 equal to 0. First you take homogeneous equation and then find the roots of this. If it is not possible, just you find with calculator. You can get r is equal to 1.17 and 1.92 plus or minus 4.11 I. So after writing these roots, one is a real root and other complex roots. So when you have a complex roots, you find you treat 1.92 as alpha and 4.11 as beta. So find root alpha square plus beta square and theta tan inverse beta by alpha. And you put your calculator mode in radians. So then homogeneous solution is C1 into 1.17 whole power n and plus r power n, that is root alpha square plus beta square whole power n into C2 cos n theta plus C2 sin n theta. In this you plug into the above values, C1 1.17 whole power n as it is. So root alpha square plus beta square is 4.54 power n into C2 cos theta is here 1.13 n plus C2 sin 1.13 n. So the solution, that means homogeneous solution is over. And observe that on the right hand side we have 6. It is a constant. When the right hand side is a constant or a polynomial, first you check whether one is a part of the characteristic root or not. If one is not a part of the characteristic root, then write the particular solution as q, because the right hand side is constant. And now put a and p equal to q in 1. Then what happened? Q minus 5q plus 25q minus 24q equal to 6. After simplifying, you get q is equal to minus 2. So particular solution is minus 2. For the complete solution in inhomogeneous solution, inhomogeneous relation is an is equal to anh plus anp. That is homogeneous solution plus particular solution. So you just write down an is equal to not anh, an is equal to C1 into 1.17 whole power n plus 4.54 whole power n into C2 cos 1.13 n plus C2 sin 1.13 n minus 2, because a and p is minus 2. You don't write anh, it is anh plus a and p value. Now, 8th question is solve Fibonacci relation. The Fibonacci recurrence relation is an is equal to an minus 1 plus an minus 2 with initial conditions a naught equal to 0, a1 equal to 1. This is second order recurrence relation. Now taking into left hand side, an minus 1 minus an minus 2 equal to 0, and then write the characteristic equation r square minus r minus 1 equal to 0. So this is not possible by factorization. So use quadratic formula, that is minus b plus or minus root b square minus 4ac by 2a. So plug into this formula, you can get two roots. Those are real and distinct. So when alpha beta real and distinct, simply put into the formula c1 into alpha power n plus c2 into beta power n. This is the homogeneous solution. But we have initial conditions. When you have initial conditions, use these initial conditions for finding arbitrary constant c1, c2. Now put n equal to 0 in 1. Then a naught equal to c1 plus c2. A naught is 0. So we have c1 plus c2 is 0, one equation. And put equal to 1 in equation 1. Again, we have a1 equal to c1 1 plus root 5 by 2 plus c2 1 minus root 5 by 2, which is simplification to this. Now solve 2 and 3. You get c1 is equal to 1 by root 5, c2 is equal to minus 1 by root 5. Therefore, the solution is an is equal to, you simply substitute c1, c2 in this equation 1. You can get an equal to 1 by root 5 into 1 plus root 5 by 2 whole power n minus 1 by root 5 into 1 minus root 5 by 2 whole power n. Okay. Now we go for another question, which is a graph theory question. Define minimum spanning tree and describe in brief about Prim's algorithm example. So write a definition of spanning tree. A spanning tree of a connected graph G is a subgraph which is a tree and which includes every vertex of G. And a minimal spanning tree. A minimal spanning tree of a connected weighted graph is a spanning tree of least weight. That is a spanning tree for which the sum of the weights of all its edges is least among all spanning trees. Now, Prim's algorithm is, we have three steps. Select an arbitrary vertex vi and choose the edge with the smallest weight in J. Select another edge ej with the smallest weight joining the vertex vi. Repeat step 2 until all n minus 1 edges are added in the tree. Now consider a graph. This is a weighted graph. First, you choose okay. First, you choose any vertex. I choose here vertex v1. Now choose minimum weights. We have v1 to v5, which is 3, v1 to v2 4, v1 to v3 3, and v1 to v4 again 3. So here two minimum weights, that is V1, V5 and V1, V3. These are the minimum weight. So you can choose any one of the edge. If I choose this edge V1, V3, and now you check V1 to V5, V1 to V4, and V3 to V2, V3 to V4, and collect all minimum weights and take minimum weight. Collect all the weights and choose minimum weight, but do not form a cycle. So here I choose V3, V2. Next, again you choose minimum weight which do not form a cycle. Next, I choose V3, V2 already I choose, and then collect minimum weights. V2, V4. So because it is minimum weight is 1. And again collect the weight and choose minimum weight, but do not form a cycle. Okay, next V4, V5, which is the minimum weight. Okay, now I visited all the vertices. When I visit all the vertices, then you stop it. So finally we have a graph like this. So this is a minimal spanning tree, and minimum weight is and minimum weight is, you write the minimum weight, that is 2 plus 1 plus 3 plus 2, 2 plus 1 plus 3 plus 2. So that is 2 plus 1 3, 3 plus 3 6, and 6 plus 2 is 8. This is minimum weight of a spanning tree. You write in like this. Next one is, how many vertices will the graph contain 6 edges and all vertices of degree 3? So given that number of edges is 6, but we don't know number of vertices, but we know the vertices of degree is 3. So by sum degree theorem, sum of degrees of a graph is equal to twice the number of edges. It is it given that all the vertices of degree 3, that is 3 into v is equal to 2 into 6. So number of vertices is equal to 12 by 3, which is 4. That's enough. Thank you very much.